All right, folks, it's Bass Action back in action here. Hope you guys are having a great Friday. And our notes in this video aren't going to take us too long to do here in class. So on your desk, what I would like you to have out is your notes packet, obviously, your Chapter 2 notes packet open to page 5. But then I would also like you to have your yellow foldable opened up to that front left window where you filled out all those conditional statements in the video last night. So I'm going to move on, hoping that you have all those things out on your desk. Starting here at the top, counterexample. Last night in the video, I went through a counterexample and said that symbolically it is going to be expressed as P and not Q, meaning it was something that satisfied the hypothesis and failed the conclusion. So that means that if our hypothesis of the conditional is true, it satisfied that, and the conclusion was false, meaning it failed it, then the entire conditional itself was false. The way I wrote those out in words last night in that video, I would strongly encourage you to do when you are asked to find a counterexample. What I'm not sure if I mentioned in the video last night is that this is in fact the only way that we can prove that a conditional is false. It's the only way we can find that hole to sink the boat and find a single example that proves it false. The reason why it's our only way is because we cannot know what happens with the conclusion even when the hypothesis is not met. In other words, if this is a false, this has not been satisfied, I have no idea what's going to happen here. So what we do in the world of mathematics is we just assume, it sounds weird, we will just assume that the conditional is true even when the table will show that that hypothesis is false. Now, what might help you is if we actually jump to the example at the bottom of the page before I start filling out the T-chart, because it walks through that idea. Sometimes students like to see this first, so we'll give this a shot. I have a conditional statement here. If it is Saturday, then Wendy will sleep until 8 a.m. This is my P, then Q. What the statement or the assumption up above says is that if I have a not P, meaning in this problem, if it is not Saturday, in other words, what if it's Sunday, then I don't know what's going to happen here. So that would make sense here. If it's not Saturday, meaning if it's Sunday, could Wendy sleep until 8 a.m.? Well, sure, Wendy could. She might not, but she could. And that question right there is what makes this a question, which is why then we just assume. Okay, since we don't know, we give it basically, the benefit of the doubt, and we just assume it's true. So the only way, back up to the top, the only way to prove that something is false is to meet our counterexample requirement that we have right there, a P and a not Q. So when we jump into our big truth table here, that's what we're going to consistently look for. We are consistently looking for each time a P and a not Q. Now, I've initially already filled out much of this T-chart for you. I gave you that start. I told you guys last time that this is the standard for how all T-charts get filled out. It's not a requirement, it's just a standard. So we could also fill in our two negation columns. So when we get to our analysis, we just have to reference it. So let's fill in our not P. That means we're going to flip all of the P column right here. We did this last time. This will become then a false, a true, and a true. Then we're going to fill in the not Q by flipping all of those. So that will become my false, and a true, and a false, and a true. The other thing that we did in the video last night was I looked at these new conditional statements and I gave them each names. You need to be comfortable with both their symbolic notation and their names. So some note cards, making some flashcards, we've been doing that, might be really, really helpful for you. The P then Q we called the conditional. The not Q then not P, that's our second one right here. We called this one the contrapositive. The Q then P, we called this one the converse. And the negation of P and the negation of Q, the negation of Q, we called that the inverse. Okay. So you need to be comfortable recognizing each of those. You need to have a way that you remember them. I remember the conditional is, of course, simply P then Q. I remember the contrapositive is the negation and the reversal of them, and I remember it because this is the most complicated and it's the most complicated word. I remember the converse just flips the order because I think of it as like a small child that put their Converse shoes on the wrong feet. They just did them backwards. And then the inverse keeps the order and just negates them. It's the one that's left over. So as we start to fill out this T-chart, in order for me to show that P then Q is false, the only place that it will be false is where the P is true and the Q is false. So I'm looking for a P then F, a P then not Q, or a T then F. Now I'm going in this direction, P then Q, because I have to follow this. So as I scroll down, as I scan down this, I'm looking for the place where I have a true and then a false. So it's not this one. There's my true then false. So this is my true then false right there. So that makes this the place where the P then Q is false. All the other ones then will be true. They have to be true from what we've talked about, okay? Now, if I go to the next column, the not Q, then not P. Again, I need this to be a true and this to be a false. So now I'm going to go in this direction because it's the not Q and then the not P. So I'm going in this direction. So I'm going to just look down this column here. There's a true, there's a false. So now I'm going to look in this direction, and that gives me this one is the false, and all the other ones are true. Now, what might be a little bit helpful for you to do is to do a little bit of color coding here. So on our P then Q column, we got this false here. This one came from this analysis right here. So we did this comparison here. So it might help to kind of match those. And then to get this one right here, to get this false, we looked at this one. And those arrows that I did are helpful because it helps you see the true, then the false, the true, then the false. So just a little matching up there might be helpful for us. Now, Q then P. I'm back to the original two columns, but I'm going from right to left. So as I go down the Q column, I'm looking for where I have a true and then I have a false. So it's not there. I can skip over that one. Here's my true, there's my false. So this is the one I'm looking at. So I'm going to make my arrow go in that direction. This is going to be my false. Then all the other ones will be true because that's the only way that I can prove that something is false. So again, if we want to do a little bit of some color coding here, it might be helpful for us to see that this false right here, this one, kind of colored that one in a weird way there. I'll go back to it in just a second here. This false right here came from this analysis right there. Then our last one, now we're looking in the negation columns again. We're going to go back to starting with the P, then we're going to look to the Q. So now we're going to go in this direction. We're going down the P column, the negation P column, and we're looking for a T, then an F. So we can't find it yet. Here's our T, then our F. So this is going to be our false right here. And again, if we want to do a little bit of color coding, that's sometimes helpful. This false right here, and I'll go back and fix that color again, came from this right here. And again, I'm just going to fix my colors for you here. This false came from looking in this direction. Then all the other ones are going to be true. Now, we're not going to do a ton of filling out these. The biggest thing, the biggest takeaway that I want you to have from this is I want you to look at the columns that we have left. I want you to look at this column and look at this column and notice these are both true, these are both false, these are both true, these are both true. These two columns match perfectly, and that should make sense because the other thing that I said in the video last night is that the conditional and the contrapositive are equivalent statements. These are equivalent statements, meaning if I get a true for this one, I get a true for this one. If I get a false for this one, I get a false for this one. True here, true here, true here, true here. These should always give the same answers. The same thing happens in these two columns. Notice that they match, they match, they match, they match. Because as we discussed in the video last night, these also are equivalent statements. So, no matter what you get here, you should get the same here and vice versa. These will always, always, always match. So, that's all that I need you to be able to do with this. The big takeaways here are remembering symbolic notation and the name that goes with it, remembering which ones are equivalent statements, and remembering that the only way to get a counterexample to prove something is false is to use a P and not Q. Now, for the rest of class, you're going to have some things to work on. I want you to discuss this, ask some good questions, and we will talk more about it and practice more next week.